Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Abdul Malik. I would like to present my thesis about generation of high voltage. Okay, this is my chapter. My chapter is first chapter 1 is generation of high voltage direct current, and second chapter is generation of impulse voltage. Okay, first is chapter 1 is generation of high voltage direct current. For the introduction, as we can know, the transmission and distribution of electrical energy start with the direct current, and the transmission line is built between this mesh and the Munich in the Germany. At that time, the conversion between reservoir consumer voltage and the higher DC transmission voltage could only be realized using rotation DC machine. Okay, as a simple, this voltage conversion is a simple, and the AC transformer allow high power level and high insulation level with one unit and has a low losses. Okay, this for introduction. However, the high voltage AC transmission link have a disadvantage, which may can change to DC technology in inductive and capacitive element of overhead line and cable put limit and transmission capacity and the transmission distance of a AC transmission link. Okay, the a little bit for the introduction. Okay, let's move to the part of the high voltage direct current. Okay, the first, as we can learn, they have four common type of high voltage direct current generator circuit, which are half period rectifier circuit, and second full period rectifier circuit, third Cockcroft Walton doubler circuit, and Cockcroft Walton multiplier circuit. Okay, the first type of high voltage direct current is half period rectifier circuit. Okay, the concept is similar to the normal single phase half wave or bridge rectifier circuit, such as you can see the figure. This is a simple and a most basic rectifier circuit. Is equipped for a large amount of testing and use a relatively simple component. And for the connection, half period rectifier circuit, a voltage V1N and high voltage winding is connected to the test object via capacitor, and the capacitor is used to reduce the ripple factor. The effect with and without this unit can be figured at this figure. And the diode is connected at the high tension of the terminal of the transformers. You can see RL is a load as a resistance. Okay, this is a type. This is no smooth capacitor causes a large ripple factor. And the second, with smoothie capacitor reduce the ripple factor effect. You can see they have some the capacitor. The effect is to reduce ripple factor. Okay, next is a full period rectifier circuit. Okay, this concept also similarly same as a half period rectifier circuit. They have full wave and bright rectifier circuit. And you can see the figure 1.4. This is type full period rectifier circuit. You can see the load voltage very smooth. And then for the connection, full period rectifier circuit board and the high voltage winding of are connected with the individual diode, diode 1 and diode 2. Each of this diode can conduct one circle. In the circuit, the ripple is reduced. The reduced frequency is twice, dua kali ganda, the value of the supply frequency. You can see it reduced 2 times. Okay, next is cockroach Wilton double circuit about general. This is for the general. Okay, both of the previous discussed the full period and half period. They have produced a DC current at DC voltage less than the AC maximum voltage peak voltage, and the double circuit produce a DC voltage almost a double peak AC voltage under the load condition, and the circuit has been named after its creator, Grancher, or also known as Cockcroft Walton. Okay, this is a circuit for Cockcroft Walton double circuit, and then this is block diagram. You can see they use capacitor and diode, same as full period rectifier, and they're using AC supply. And then next, this is a voltage curve under no load. As you can see, the graph is straight because they have peak V peak. This is the output V peak, and this is a voltage curve under load. You can see they're very smooth. And then this circuit that has, okay, as you can see, for the circuit no loading condition, this is the F condition. Okay, for the loading condition, based on figure 1.6, they have no load. The terminal O of high tension secondary winding is earth. When the potential O become negative, considered by 0, and during the first negative half circle of the voltage wave, the diode D conduct this causes the potential O and the half period rectifier circuit state, and they also at this stage they have causes the capacitance they charge up to the voltage Vmax, and then get the peak value of the AC voltage. And by neglecting the diode drop the potential of A, which voltage current is 0 during conduction of D, and the potential of 0, which is voltage output they reach, and then the Vmax when the supply voltage is at negative peak. And they also have a lossless charge from capacitance, and they always be equal, and they also have a losses of the charge from capacitor. is potential that shall always be equal to Vmax after the instant x. Can and Va will oscillate between 0 to 2 Vmax as V output oscillate from negative Vmax to positive Vmax, and the diode start conduct when this stop conducting at instant x, and the capacitor is changed to 2 Vmax at the instant of y of the Va curve. At, at this instant, this stop conducting. If there is no load, the R equal to infinity. The output voltage will be constant at 2 Vmax, positive 2 Vmax from the instant Y outward. Okay, you see? From Y outward. Okay, that for no loading condition. Okay, next is loading condition. Okay, based on figure. This figure. V out will be less than 2 Vmax when R equally infinity, and the circuit have a load. You can see they have load, and then the reduction of the voltage magnitude based on two reasons. Firstly, due to during non-conduction period, capacitance supply the load current and load voltage will be less than positive 2 Vmax due to ripple. You can see the ripple. And second, during each circle, the capacitor C replaces the charge lost by capacitor in supplying the load, and this result Va never attain at potential positive 2 Vmax, and capacitor C is not charged to positive 2 Vmax at all. Okay, for the connection, the circuit, one output of the high voltage winding is earth, and the circuit is arranged with the position of the diode 1 and diode 2, and the capacitor 1 and capacitor 2. They are arranged such as illustration this figure. You can see this figure. See capacitor 1, capacitor 2, diode 1, diode 2. And the diode prevent the voltage at the point A from becoming a negative concerning earth. This result is a sine wave of 0 volt to twice the peak of transformer secondary apparent at this location. And the charging of the positive and negative half circle of AC sinusoidal supplies voltage allowed at the depend on component position. And then this configuration enable the production of the DC waveform with an output voltage of 2 Vmax, and the produced DC waveform voltage have a positive 2 Vmax at no load condition. As you can see there at figure 1.9 1.6. Okay, there has a problem about this circuit. The voltage drop occur during a loading condition, and there a load resistance. Okay, the result in voltage output less than positive 2 Vmax, such as that show at this figure. You can see. Okay. And and this caused by two reasons is during the conduction period, the smoothing capacitor 2 supply the load current will be less than 2 Vmax due to ripple and during each cycle. And the capacitor 1, the charge lost by capacitor 2 in supplying the load causing the VA at node A in figure 1.9 at 1.6 to never attain at potential V2 Vmax. So the capacitance C2 is not changed to to positive 2 Vmax at all. Next is Cockroach-Welter multiplayer circuit, and this circuit is also known as a Cockroach-Welter cascade circuit. It extension of the previous discussed about Cockroach-Welter double circuit. This is same but the upgrade to the multiplayer circuit. As you can see, this is a circuit about Cockroach-Welter double circuit, and then this is the new one, a two-stage Cockroach-Welter multiplayer circuit. Okay, this configure produce output voltage at 4 because the multiplayer they have double 4 Vmax during no load condition. You can see and then show the stage and stage cascade circuit the output equal to Vmax under no loading. As you can see, this is a figure. There are two stage Cockroach welder multiplayer circuit, and this is the end stage Cockroach welder multiplayer circuit. And a charging of a smooth column. This is the charging of the smoothie column, and this is a charging of oscillating column. There's a problem about this Cockroach-Welter cascade circuit that's similar to previous mention for double circuit and extended. The circuit stage also have a problem with voltage drop during loading condition. Every voltage multiplier stage that are used in a DC system add on an extra voltage. And extra voltage drop to the system, and the voltage drop is proportional to the load current and is inversely proportional to the supplier frequency. The next result is that it is not economic to use more than 5 multiplayer stage in series, and DC set with HV laboratory also often use higher frequency power supply to limit this voltage drop. Okay, and then for the conclusion for this high voltage DC current, it is very important issue in transmission energy. In near future, this technology probably will be developed very intensively and competitive elevation studies application different schematic and review of the high voltage DC current system and presented in this part of the paper. Now is chapter 2, generation of impulse voltage. For the introduction, the impulse voltage can be defined as an indirectional voltage which rise more or less rapidly to a peak value and then decays relatively slowly to zero. Okay, the first input is impulse generator. The principle of the generator to the generate an impulse voltage or current waveform. It uses a combination of capacitor and resistor and spark gap in generating the impulse waveform. They depend the capacitor and resistor value and circuit configure. They have positive and negative polarity. Lightning and switching waveform can be generated from the set. Yeah. And the voltage or current magnitude of the impulse waveform is depend the number of stage circuit that is used. High magnitude required multiple stage circuit, and this 10 stage circuit is required to generate about 1.5 megawatt the impulse waveform. And the impulse generator set can be categorized into two is single state circuit and multiple circuit. And for the problem of this impulse generator, the unit is very expensive, especially for the multiple circuit set, and handling the test is very dangerous. And the handling person must be competent enough to set or conduct the unit and test experiment. It is difficult to produce the voltage magnitude at the required level. The required accurate at 100% efficiency, especially at the higher voltage level. And the efficiency of the voltage generated lies from 0.6 to 0.9. And they also requires sufficient large test area that with a good safety component in place. Impulse generator uncontrolled. In simpler form of the single state impulse generator shown in figure 2.1. Okay, this 2.1 the uncontrolled operation and peak value of the supply. The high direct voltage required is obtained for the high voltage transformer through a high voltage rectifier, and the direct voltage need not be smooth, as it only must change the first capacitor to peak value. And they have a separate gap. In the uncontrolled operation, the breakdown voltage of the sphere gap is less than the peak value of the supply. So that is efficiently close when the voltage across the gap build up above its breakdown value. This is sphere gap. And then the capacitor will then discharge through the impulse generator circuit, producing an impulse waveform. The subsequent the capacitor will charge up again, and the process will be repetitive. And however, as the breakdown of the separate gap is not exactly a constant but statistical static, constant is static. The time of occurrence of the impulse nor the exchange magnitude are controllable. You can see this is not constant but the static time. The next is a single state impulse voltage generator. The single state circuit are mainly used for the generation of really low impulse voltage, and they have already used at the UTHM high voltage laboratory capacitor feeder lightning impulse at maximum 140 kVp. You can see this is a figure of the single state impulse generator equivalent circuit, and it's a single state impulse generator equivalent circuit. They have two types, the wave tail circuit and wave front circuit. For the connection of single state impulse voltage, effectively two circuit. You can see this figure. From the overall wave shape, rise and decay line, the stage of capacitors is initially charged to high voltage direct current voltage and is discharged via a switch of spark gap. Example, spark voltage around 50 kV is created externally using battery operate circuit. Okay, when the switch gap is triggered, they automatically close. That means trigger is closed. Immediately the capacitor voltage appear across the tail resistance at the gradually start to reduce its magnitude. This tail waveform is created, and this is wave tail circuit at this figure. Upon the conduction of the wave tail circuit at the same time, the voltage across the tail resistance causes the voltage to begin to build up across the front capacitor. They create rise waveform. And this is usually the voltage divider. The test object is connection across the front capacitor and is due to the part of the circuit that the voltage waveform cannot rise to peak instantaneously, and the time constant of the front capacitor and the front resistance will easily be much lower than the time constant of the stage capacitor. You can see this is the figure. They have a switching waveform and the lightning waveform. This is the Terco single stage circuit lightning impulse test setup. This is set up at UTHM. This is the equipment. 140 kVp that be at UTHM to testing using Terco lightning impulse. You can see this is the single stage lightning impulse generator. Okay. Next is multiple stage impulse voltage generator that equivalent circuit. MUX circuit. Okay, multiple stage impulse voltage generator is not possible to scale up the capacity of single stage impulse generator to generate high voltage magnitude. Example is 500 kVp due to two reasons. It is problem with the they too expensive, cost and difficult in supplying high voltage DC, and problem with the need to increase size of high voltage capacitor. And the MUX generator is used to generate and a high magnitude impulse voltage. This generator use a number of capacitors that are changed in parallel and through the high ohm resistance before being discharged in series through spark gap. You can see this is the multi-stage impulse generator Mach circuit. Okay, this is Mach circuit schematic diagram. Okay, you can see, and this is when the Mach circuit they have some a little bit modified to find the with the capacitor. Okay. And then they have a full stage Mach generator equivalent circuit, the A, B, C, D. You can see this is the stage, four stage. Okay, let's explain the connection. The connection that shows schematic diagram have four stage. They have capacitor and resistor and four oscillate tail resistor and dumpling resistor. And the DC voltage charge the stage capacitor have four number in parallel. Through the high voltage change resistor as well through tail resistor, which are smaller value than RC. That means R capacitor. This charging resistor act in the same way as the tail resistor are when the generator discharge but usually of the high enough value to allow the tail resistor to dominate. Okay, this is the the explanation about this circuit. At point A, B, C, D will acquire the potential DC source V with respect the point G. You see the point G and the point H I J K will remain at earth potential. Okay, you can see this is the earth potential as the voltage drop across the tail resistor and during a charging time. Therefore, the load capacitor remain the earth potential 0 volt during the charging of the state capacitor. The spark gap G1, G2, G1, G2, G3 and G4 are set to spark almost simultaneous. Okay, the charging of the generator is accomplished by applying an additional impulse voltage around 15k volt and the sparking voltage example battery operate to the spark gap. The spark gap will trigger and since the sphere gap is normally set to just hold off the charging voltage and the presence of this additional impulse spark causes of the first gap is G1 to break down. When this occurs, the potential base of the second stage capacitor point H is changed from 0 volt to 0 volt to volt capacitor. And then the capacitor effect, the second gap still has a potential at the tail resistor side but the voltage of V to VC across it causing immediately breakdown the alternating. This situation continues across to the top of the generator where spark gap breakdown and potentially across point C at 3 volt. Then the spark gap breakdown, spark gap G4 breakdown and the potential across point D is a 4 volt. They also contain in the generator design are dumpling resistor. They actually from a part of the front resistor that installed internally to the generator. Okay, this resistor help in controlling oscillations in the voltage waveform that may arise when the inductance is contained in the test lead, and this dumpling resistor small in comparison to the tail resistor. The front capacitor CF is used in the creating the wave wavefront impulse and also rack as a voltage divider that measure the wave shape production by the generator. You can see this is a 2 megavolt impulse generator set at Manchester United. You can see this is a capacitor divider. This is impulse generator. This is prototype to test. Okay, for the conclusion, from this conclude can know about impulse generator more detail with the testing using a lot of equipment to find measure impulse voltage measure technique in the high voltage engineering. That's all from me. Thank you.